Hello, everybody, and welcome to Alex Derives Stuff. Today, I am going to show you how to construct a circle through 3 given points in the XY plane. And as a little warm-up here, what I wanted to do is use GeoGebra's geometry tools to show you how you would construct this geometric with nothing but a straight edge and compass. So the geometric construction, so first of all, we need 3 points. Okay, so there's, I don't know, 3 random points, sorry, A, B, and C. And you could do this with any 3 points located anywhere. The first step, I'll call the 3 points A, B, and C, and we want to construct a couple of perpendicular bisectors. So to do this, there's a pretty simple way to do this with nothing but drawing circles and straight lines through points. You could draw a circle with center at A and edge at B, and then you could draw another circle at B and edge at A, and then you could draw a line through the intersection points of these two circles. So hopefully there's no doesn't feel like there's a snap to effect here, but there we go. So this line is the perpendicular bisector of AB. So what that means is that if I drew a line that went through A and B, which I could do, so there's a line through A and B. It's perpendicular to that line, and also it cuts through the midpoint of that line. So what I'm going to do is I'm going to make all of these circles smaller so they don't clutter up the picture so much. And I'm going to make these lines a little thinner, and I'm going to make that one green, and then this one a little thinner, and this one blue. All right, so the blue line, so the green line is the one that goes through AB, and the blue line is the perpendicular bisector of line AB. Now, why do we care about this line? Well, the big deal about circles is every point on a circle is the same distance from the center. So if A and B are on the same circle, then the center of that circle must be the same distance between A and B. And so the center of the circle will be somewhere on the blue line. That's the idea. Okay, so if we could do the same thing with, say, B and C. So if we wanted to, we could draw a line through B and C, and that would be equivalent to the green line there. So this would be green, and let's make it a little thinner. Okay. And then we want to do the perpendicular bisector. So to do that, we do circle with center at B, edge at C, circle with center at C, edge at B. By the way, I don't need to draw these green lines right here for the full construction here, but they're useful visual aids. And I'll make these circles thin and different colors. I'll make them sort of red, and but I'll make it thin. And then I'll make this circle thin and red. There we go. And so now we want it, so our perpendicular bisector for B and C will be another blue line, will be through the intersection of these two red circles. So boom. Boom. All right, that's close enough. And then again, I'll make this line blue and make it a little thinner. Okay, so the two blue lines are our perpendicular bisector. So basically, the first blue line, the one through D and E, that one is, every point on that line is the same distance from A and B. And then the line through F and G, that every point on that line is the same distance from B and C. So the intersection point, the point that's common to both lines, that, I guess it's H in this construction, is the same distance from A, B, and C. So that point H right there, that intersection of those two blue lines. So by the way, so there's our perpendicular bisector of B and C. Then this intersection of our two lines, that is the center of our circle. So then now we can just draw our circles. If I go back to my geometry things, I can draw the circle with the center at H and edge at A, and lo and behold, this circle goes through all three of our given points, A, B, and C. So that's the geometric construction right here. And so the big deal here is this. So we need to find a point that is the same distance from all 3 points. And it's easy in the plane to find all the points that are the same distance between 2 points. That's the perpendicular bisector. And so so it boils down to find the center of the circle is the intersection of 2 lines. Now, how do we translate this into an algebra problem? Well, using vector algebra, we can solve this. So I'm going to move this stuff over to my OneNote. Okay, so to aid us in the algebraic, in the description of this, what I have here is a specific example. So I've got a specific 3 given points with their coordinates given, points A, B, and C. A is the point 2, comma 1, and you can see I've got it drawn on my little hand-drawn graph there. That at least I've got graph paper as my background, so I can be somewhat accurate with this. B is the point 3, comma 5, so 3 in the x, 5 in the y, and C is the point 5, comma 3, so 5 in the x, 3 in the y. And so our goal here is we're going to find the circle that goes through all 3 of these points. And so we're going to follow the same procedure here. So one, we need to construct a perpendicular bisector of A and B. And so we need to locate so first thing we got to do is we got to locate the midpoint of A and B. So what is the midpoint? Well, let's see here. If I draw, say, like a little green thing. Oh, no, it shouldn't be green, maybe blue. So here's the line connecting A and B. That's not a very good line. What just happened here? There is roughly, this thing is really not liking my left-handedness. The line connecting A and B. All right, that's a terrible line, but you get what I do, the idea. So where's the middle of that? Well, the way we get the midpoint of the line is we just average the x coordinates and the y coordinates. So maybe if I erase that line, I'll just draw the midpoint. So P, I'm calling this P. So ax plus bx over 2. So px would be, so ax is 2, bx is 3, so 2 plus 3 over 2. So that's 5 over 2, so 2.5. Py would be ay plus by over 2, so 1 plus 5 over 2, which would be 3, right? So 6 over 2 is 3. So the point P, so we'd go over to 2.5 in the x direction and 3 in the y direction. So the point P right there would be our midpoint between A and B. And you can see, like, even with this rough scaling here, it's pretty good. That looks to be the midpoint between A and B, right? You just average the 2 points. Cool. Now, once we get that, we want to construct the vector AB. So let's see here. We want a shape. Let's do an arrow. So the vector AB. There we go. There's the vector AB. And so algebraically, what this vector would be is B minus A. There, whoops, got a little ahead of myself there. So the vector AB is equal to, so be 3 minus 2, so 1, and 5 minus 1, so 4. Okay, and so in other words, to get from A to B, you go 1 in the x direction and 4 in the y direction. Oh, okay, easy enough. So this vector right here is perpendicular to the line that we want. The line that we want goes through P and is perpendicular to this vector AB. And so that's why I called it nx and y. It's a normal vector to our line, and so we can use the normal form for the equation of a line. So the equation of our line that is perpendicular to this would be, so we got nx plus ny, or nx, so there's 1. So our line would be 1 times x minus 2.5, and then plus 4 times y minus 3. Okay, and you can see that it then equals 0. And then that line, let's see here, I draw another, I'll just draw another line. So if I go down 1/4, I think, about there. Let's see, 1, 2, 3, 4. Yeah. Okay, cool. All right. So there's, and then if I extend this line, so the equation of that red line right there would be, in fact, x1 times x minus 2.5 plus 4 times y minus 3 equals 0. If we like, we can rewrite this in like y equals mx plus b form. Okay. All right. So we could do the same thing. To find the perpendicular bisector of B and C. So for B and C, so the midpoint of B and C, we can call that like Q or something. So let's say Q equals, so 3 plus 5 over 2. I guess it would be a point. I don't need the things. So Q would be 3 plus 5 over 2, comma 5 plus 3 over 2. I believe both of those end up being 4. So Q equals 4, 4. So this is our midpoint. So if I go to 4, 4, that's about there. There's our midpoint of B and C. And then now we want to figure out the vector BC. So the vector BC equals C minus B. So 5 minus 3. So that would be 2. And 3 minus 5. That would be negative 2. Okay, and as you can see, to get from B to C, you go 2 to the right and 2 down. So yeah, so I'll draw a little arrow for that. So there's my vector from B to C. Okay, and then I want to draw a perpendicular. So the equation of the line that is perpendicular to this would be, let's see here. So so the BC would be our normal vector. So we get 2 times x minus 4, right? Because 4, 4 is our point, and then minus 2 times y minus 4 equals 0. And so that's the equation of this line that's perpendicular to this. So, so if I do a line, that would have a slope of -1. So that would be like sort of that way. Okay, roughly. Okay. All right. So now again, my drawing here, I'm being really rough with this, but like the intersection point of these two lines appears to be about, what is that? 3 for x and a little less than 3 for y. Okay. So now what we could do is we've got the equation of the two lines. We need to find the intersection point, and then that'll be what we're going to call O for the center of our circle. So let's see here. So let's solve for this. So line 1 is x minus 2.5 plus 4 times y minus 3 equals 0. Line 2 is 2 times x minus 4 minus 2 times y minus 4 equals 0. This is two linear equations and linear unknowns, so we could solve for x and y here, and we should get something that's relatively close to that dot in my rough drawing, right? So let's see here. So if I distribute the 4 there, so in the first equation, so I'll call this 1 and this 2. So if I rearrange equation 1, seems like it's easier to solve for x. So we get x minus 2.5 plus 4y minus 12 equals 0. And I may want to revert to fractions here if I want a more precise answer. Seems easier to solve for x. So x plus 4y equals 14.5 or 29 over 2. So we could say x plus 4y equals 29 over 2. And then if we solve for the x, we'll get x equals 29 over 2 minus 4y. Okay, now, so I'll put that in a box. I'll probably what I want to do is first simplify equation 2, and then make the substitution. So if I clean up equation 2, I got like 2x minus 8 minus 2y plus 8 equals 0. Interesting. And so then I guess that's, oh, the 8's cancel. So we got 2x minus 2y equals 0. Or x equals y. Oh, that's interesting. So, all right, so if we plug in x equals y into the first equation, we get y equals 29 over 2 minus 4y. And so 5y equals 29 over 2. And y equals 29 over 10. Or if we want to write this as decimal, 2.9. Okay, so and then our x coordinate is the same thing because x equals y. So our center of our circle, which is the intersection of the two perpendicular bisectors, is 2.9, 2.9. And if we go back to our picture here, like, okay, so actually that's pretty close, right? That's a little less than 3 and about 3. So again, there are some drawing inaccuracies here. If you notice, I didn't put the corner of that second perpendicular bisector quite on the line. So, but that's, for my rough drawing, that's pretty good. Okay, so now what's the radius of the circle? So I'm calling this OX, OY. So this would be 2.9, 2.9 would be our point O. All right. So the radius of our circle will be the distance from O to A. Now, granted, we don't have to use O to A. We could just as easily use O to B or O to C. That was the whole point, is this point O is the same distance from A as it is from B as it is from C, right? That's how we know it's the center of the circle. But so I just picked A because it was the first point. And if you remember, A was the point 2, 1, right? And so the way we've got our point O is 2.9, 2.9. And then we've got our point A, which is 2, 1. And then the vector from O to A. So that's A minus O, right? So that would be 2 minus 2.9. So negative 2.9. And then 1 minus, no, not negative 2.9, just negative 0.9. All right, so that would be negative 0.9. And then the 1 minus 2.9, so that's negative 1.9. So that's the vector from O to A. And then the magnitude or the norm, or the length of this vector gives us the distance from point O to point A. So our distance from O to A. Now, this will be the square root of 0.9 squared plus 1.9 squared. We can discard the negatives when we square it, because if you square a negative, you get a positive. Okay, so whatever this ends up being, now if you get out a calculator, or if you want to do some fun fraction work, what you end up with is the square root of 221 over 50, which if you wanted that as a decimal, that would be about 2.1. So about 2.1. And so let's sort of go up here. So the distance from O to A, it looks like it's a little more than 2. It's like a little less than 2 down and a little less than 1 to the left. So yeah, that's about 2.1. Or B looks almost directly on top of it, actually, right? So it's a little bit to the right of it. So yeah, that's about 2.1. So that's our radius. So our radius is equal to the square root of 221 over 50. Cool. So we have our center, that's point O, and we have our radius. And if we have our center and our radius, we can get the equation of the circle. X minus the x coordinate of the center squared plus y minus the y coordinate of the center squared equals the radius squared. So that's why I had the radius written as a square root, do that, because I'm just going to square it when I write out the equation of the circle. So the equation of the circle is x minus 2.9 squared plus y minus 2.9 squared equals 221 over 50. If it bothers you, me mixing my decimals and fractions, feel free to change the 2.9 is in fact exact. You could change it to 29 over 10 if you like. So that doesn't reduce any. 29 is prime. So there we go. So that's our procedure here, and it works all the time. So the big new thing here is probably you're not used to finding the equation of a line the way we did, where instead of using a slope, we used a normal vector. However, if you're familiar with the equations of a plane, that's actually how you find the equation of a plane. So there is a way of finding the equation of a line using a normal vector and a point, as opposed to a slope and a point. All right, I hope everybody enjoyed that. You now know how to find circles in the plane if you are given 3 points.